Hello, my name is Dan and I'm going to briefly be talking about cache memory mapping functions as well as replacement algorithms. Cache memory mapping functions are an integral part of cache memory, and they're basically responsible for how data is stored and retrieved within the cache. There are various types of these functions, but the main ones I'll be talking about in these slides are direct mapping, set associative mapping, and lastly set associative mapping. To begin with direct mapping, this is actually the simplest form of memory mapping function, and it is commonly used by many computers. In direct mapping, a memory block is mapped directly to a specific cache line using a specific mathematical function. For example, if we have a four-way set associative cache with a total of 16 cache lines, each memory block will be mapped to the specific 16 cache lines. For example, if we have a four-way set associative cache with a total of 16 cache lines, each memory block will be mapped to a specific cache line based on the modulo operation. For example, if the memory block's address is divisible by 16, it will be mapped to the first cache line out of the total 16 cache lines that are there. And if the address of the second memory block is divisible by 8, then it will be mapped to the second cache line, and so on and so forth. Moving on to associative mapping, which is a bit more flexible compared to direct mapping, since it does not assign a fixed location for the memory blocks. Instead, each memory block's address is stored alongside the corresponding data in the cache. This is an advantage because it allows faster retrieval of data, as any memory block can be stored in any memory cache line. And lastly, moving on to set associative, which in a sense is a compromise between direct mapping and associative mapping. In set associative mapping, the cache is divided into a number of sets where each set contains multiple cache lines. Each memory block is then mapped to a specific set within that cache, and within that set the block can occupy any of the cache lines. Moving on to replacement algorithms, which are essential parts of computer systems that help manage memory and optimize resource utilization. These algorithms determine which block of data are to be replaced when new requests that require additional memory space are placed. In this presentation, I focus on 3 examples of replacement algorithms, starting with FIFO, info fast in, fast out, then followed by LRU, which info is least recently used, and lastly LFU, which is least frequently used. The FIFO algorithm is the simplest replacement algorithm, which basically operates on the principle that the first page or block to be loaded into memory is the first one to be replaced. This algorithm keeps a record of the order in which pages are added and removes the oldest when a replacement is needed. The disadvantage to this algorithm is that frequently used pages can be removed, which can disrupt the efficiency of the computer system. The second algorithm we have is the LRU, which is more sophisticated in the sense that it replaces the least recently used page. It relies on the idea that pages that have not been accessed recently are less likely to be used again in the future. This algorithm also maintains a reference bit for each page and updates it whenever the page is accessed. However, also with this algorithm, pages that are useful can be discarded, and that can eventually reduce the efficiency of the system. The last replacement algorithm is LFU, which considers the frequency of the page usage rather than the recency as in LRU. It prioritizes pages that are least used and removes them from the system memory when additional space is required. This algorithm keeps count of the number of times each page is referenced and replaces the one with the lowest count. However, the disadvantage of LFU is that it has challenges in determining the optimal frequency threshold for eviction decisions, deciding when a place should be considered infrequently used and be complex, as frequency can vary over time. In conclusion, both the cache memory mapping functions as well as replacement algorithms are vital in managing memory resources efficiently.